Hi, and welcome to the Engineers HVAC Podcast, where our mission is to empower and educate the HVAC community. I'm your host, Tony Mormino with Insight Partners, and today we will be discussing clean rooms and emerging clean room technology. Today's guest is Bo Coffman, Director of New Business Development at Nortek CleanSpace and Nortek Air Solutions. Bo, how are you doing today?
I'm good, Tony. Thanks for having me.
Awesome. Thanks for joining us. I've been kind of excited about this podcast because I know very little about clean rooms.
Okay.
And I'm guessing I'm probably the perfect guy to ask the questions because I know just enough to know what to ask and to be careful with, I know that it's a serious thing. Like clean rooms are serious business. It's not child's play, as they say. And I know if you're going to do one, you better know what you're doing and have some experience or work with someone who does. So I'm glad. Anyway, thank you. I'm glad you're here. A lot of our audience are engineers, contractors in the HVAC world, and some of them range from still in college to just got out of college and starting their career. So some of them know way more about clean rooms than I do. So the way I typically like to do these is kind of pull it back, start at the basics for the new folks, and then we can touch on a little more detail.
Yeah.
And does that sound like a good plan?
That sounds great to me. It is, in general, it is not a common dinner party conversation. Mm-hmm. So I wind up having to talk a little bit more about what I actually do to people all the time. So let's get into it.
Awesome. So why don't you tell the listeners a little bit about yourself, your experience, and what your department does at Nortek Air Solutions?
Sure. Thanks. So I've been with the business here at Nortek for about 18 months now. A relative newcomer. Those on our team collectively have decades and decades of experience, which is great. I'm on a great team. The CleanSpace segment within Nortek came as a result of a couple of important things about a couple of years ago. About 2 years ago, number one, Nortek was a newcomer to being part of the Madison Industries family. Prior ownership, in many stages before that, we don't have to get into that history, but most recently, Madison Industries and their Madison Air segment, used to be called Indoor Air Quality, acquired Nortek. And that Madison Air segment is run by an extremely smart, extremely talented person, Jill Wyant, who came from Ecolab, where she ran that business. She has a unique connection and knowledge and understanding of clean room environments and the biggest end markets that we serve. So along with the support of Jill and Madison, Nortek was seeing a significant opportunity in a growth curve for clean rooms globally, and especially here in North America with some key legislation that is now passed. Our two biggest end markets are semiconductor, wafer and chip fabrication, and life sciences. On the semicon side, that CHIPS Act legislation that is fairly commonly known, it's been in the news, has really infused billions of dollars and a tremendous amount of investment and new facility build out here in America. And the industry is on this growth curve as experts within semiconductor speak about it. Between now and 2030, that entire industry is looking to grow into a $1 trillion business. So we see this 5-6 year horizon right now to really be in lockstep with that industry and keep innovating, because the technology moves so fast and the requirements for inside that clean room space are ever changing as well. So we are excited about being part of that. So the CleanSpace segment was born out of that recognition that was happening. Everything else within Nortek Air Solutions is, let's just call it every other building use. We call it commercial building uses, and whatever that may be, and that's all air handling. That's custom air handling technologies, all the kinds that we do, DX, DOAS, all of it for anything you could possibly think of: manufacturing, education, healthcare, every building use. As soon as you say clean room, that's a pretty niche but pretty growing segment, and we made that a dedicated team and dedicated vertical segment within Nortek Air Solutions, and that's what we mean when we refer to our segment internally as CleanSpace.
Excellent. Sounds like a good marriage of experience, that's for sure. And for those who've been around a while, including myself, Nortek Air Solutions has been rebranded over the years, but consists of the legacy brands Temptrol, Ventrol, Governair, Hunt Air. So if someone's listening to this, like, I don't know who Nortek is, that's who Nortek is. I think most people know that today in the industry, but I always like to start with that just in case, because I know when Nortek came out, I was a little bit confused, like, who exactly is it? So tons of experience. Yeah.
And just a quick follow up, and that you're right. What now under Nortek is looked to be product brands, Temptrol, Ventrol, Hunt Air, as most people who've been around would know, those were companies. Now they're product brands for us. The most recognizable product brands in our clean room application, our CleanSpace segment, would be Hunt Air. That would be a very recognized air handler brand that finds its way into clean rooms, and then CleanPack. CleanPack was also a company then acquired by Nortek, and now we associate CleanPack as a brand with not only the air handling technology, but something I can speak more about, our clean room sealing systems and sealing grids, and we can get into that, of course.
Excellent. Yeah, let's definitely get into that. Before we get into that, let's start kind of with the basics, because I'm a clean room novice. I know you go in there, you got these robes on, you got to make sure you don't get dirt and dust and everything in these rooms. So what is a clean room? Do we have a way to define it? And is that different than a clean space, or is that two names for the same type of area?
Sure. Yeah. At a high level, in general, a clean room is a controlled environment. If you had to say it and couldn't use any more than two words, that's likely what you would choose. It's an air quality controlled environment. To refer to it as a clean space tends to be synonymous. The other thing that's up and coming that you'll hear about out there is a dry room that has much more to do with sensitive humidity control, and what those controlled environment spaces are for. The most well-known and growing segment right now is the production of lithium-ion batteries. Needs to be in a very dry space. So clean space, dry space, clean room, dry room, they're kind of all in the same family. A clean room is used today in modern semiconductor, microelectronics, medical device manufacturing, pharmaceuticals, a whole host of life science driven applications. And it's meant to be an environment where you get to control both airborne and surface contaminants, anything that could adversely affect the manufacturing process typically, or scientific research process. Aerospace and university research uses clean rooms as well. Anything that would have an adverse effect on that process is where all of a sudden you need a room where you can control that environment, and that's a clean room.
Right. So the classic, like the way I think about it, is the semiconductor manufacturer, chip manufacturer. If one little speck of dust gets in there, it can ruin the whole product or the whole process. Is that kind of like, am I thinking about that right?
Exactly. Right. Okay. And probably the most stringent requirements would be found in the semiconductor industry. If we want to get into it, we can talk about what class levels and the basic definitions of it and how it scales from the absolutely most strict level of hardly any particulate up to depending on the process and what's required.
Yeah, let's talk about that because before we talk about that, can you talk about the size of it? Is there a general size of a typical clean room? A clean room fits two people in it, or it could be as big as a big. Like I'm not familiar with what they look like. I'm thinking of there's a couple guys in lab suits, and they go into this room, and there's 5 people in their max. But could they be bigger than that? I mean, what is a typical layout?
Absolutely, yeah. It good question. It varies greatly, actually, depending on how these markets and applications I'm describing get segmented. You can absolutely picture a clean room very much like just a room. They can be as small as 50 to 100 square feet. Generally speaking, when it's sometimes referred to as a standalone or modular clean room, something that's self-supported. It's a room inside a building, not attached to the building architecture in any structural way. Those tend to be smaller and would kind of range from 100 up to 1,000, even 5,000 square feet.
It's a box inside the building, a pre-engineered modular type box. Got it.
And in that sense, it would have everything: doors, walls, windows, the ceiling, the floor. And then there are comparatively massively large clean room spaces. The best example to give would be in semiconductor. They are, tightly protected areas. No one just suits up and walks into a clean room at one of the major microchip manufacturers. But those facilities, they rival the size of, Boeing and Airbus and airplane.
Oh, wow. So they're a big open manufacturing facility.
Yeah, there are room styles, and one is called a ballroom, literally a ballroom style clean room. Now you're talking on the scale of hundreds of thousands of square feet.
Wow.
Of clean room, every square foot inside that, which then starts to represent millions of cubic feet of space, tightly controlled to the most stringent standards. That would be the extreme case of size and challenge to keep that air quality as low as it. The air quality is high and the particulate as low as it needs to be.
That's awesome. I was thinking I have this really nice 4K camera. I'd love to go take some video, but they're probably real strict, like the data centers. They don't want anybody coming to there taking photos and pictures and everything like that. So they are
extremely protective.
Right.
Of their IP and process, and the magic happens inside that clean room.
Yeah. That's right. So classifications. I've heard like class 3 clean room or class 4 clean room, and I think those are ISO standards, if I'm not mistaken, of particulate size and maybe quantity. Am I off base there? You enlighten me on what that is. The class.
Yeah, no, you're touching on it for sure. In fact, what came about in the last several years was 2 different classes and scales. Clean rooms really started back in the 60s, and it started with the government, started with the Air Force and aerospace. And when we started building stuff that was going to go to the moon, and highly sensitive controlled environments where even back then the kind of electronics being developed was a pioneering thing from the Air Force and the government, and they needed again controlled environments from an air cleanliness standpoint. And then through the 60s, the private lab that really worked the closest with the Air Force was Sandia Labs. And through the 60s, Sandia Labs and the government, the U.S. Air Force, created a federal standard called Federal Standard 209, and it's been through several revisions, 209A, B, C, all the way up to, I think it's 209E, through the 60s. And that would be when you hear class 1, class 3. Well, in that scale, it's class 1, class 10, class 1,000. We speak that language here. We do a lot in semiconductor. Class 1 is the most strict, and literally refers to 1. I think it's 1/2 a micron particulate for every cubic foot of air. allowed, no more than that. And that's what that scale meant. And then in the late 60s, and more from an international adoption point of view, ISO came up with ISO 14644, and a scale that correlates to federal standard class 1, class 10, class 100 and above. Class 1 would be synonymous with ISO class 3. So you could, if you said an ISO class 3 clean room, or a class 1 federal standard 209 class 1 clean room, you're saying the same thing. And they just kind of work up that scale accordingly.
So I looked up the ISO standards. I was wondering why I didn't see a 1. So that makes sense. So it's equivalent to the class. So you got to reference what standard you're referencing when you're talking about. Do we normally just hear in terms of ISOs today? We don't deal with the classes anymore, or both?
More often than not, the international standard organization, the ISO scale is what you hear. Yeah, and we're trying to speak that language more and more today as well.
Got it. Okay, so we've got these particulates in the space, which are very small, and we don't want a lot of them. So can you, from an airflow perspective and filtration perspective, you've got a room. Now here's where I don't know anything about it. So is it 90% recirculated, very little outdoor air? Is there a lot of outdoor air? And then how are we filtering everything? I'm assuming a bank of HEPA filters, or you tell me kind of what kind of filtration goes on and how the air flows into the space and everything.
Yeah, sure. It all interacts together. So there's a lot to cover. Certainly you tend to start with outdoor air. There is going to be a makeup air source. But in these controlled environments and cleaning room applications, you very quickly start talking about recirculation. And the class levels we just spoke about also correlate to air changes per hour that are needed in that space. If we start in the most strictest sense, ISO class 3, federal standard class 1 clean rooms, it is the highest level of air changes per hour that needs to keep happening. And from an airflow standpoint, the architectural design of that room is referred to as unidirectional, not non-unidirectional. So then you start to see floor systems that not only are where everything is sitting because it's the floor, but there's a lot happening underneath the floor and in the subfab. But to pull air down from the ceiling in the most laminar, straight down, unidirectional path you can take requires that return air to go through that floor and then up an external chase. And then much of it gets recirculated. In terms of air handling technologies that are doing that, one would picture more traditional recirculation air handlers, RAHs. They could either be at mezzanine level above that ceiling, at another level in the building. Commonly they are. Then that recirculated air would be ducted down to ducted filters that would be in the ceiling. Plenums are also used, which typically when we say plenum in clean room design, you're kind of marrying the actual ceiling grid and an air plenum into one device. And then quite often we'll take recirculation air handlers and sit them right on top of that plenum also. So you get a fair amount of recirculation happening in that way. The alternative to all that, or the different ways you can either place or apply an RAH, would be the use of fan filter units, or commonly referred to as FFUs. Now you've taken an air handler and reduced it down to the size of one cell in a ceiling grid. Common sizes there are 2 feet by 4 feet or 4 feet by 4 feet. And it's very common to find dedicated fan filter units for that one section or that one cell within the grid. And when you're talking about class 1, even class 10, you're talking about 100% filter coverage. So there could be hundreds, if not thousands, of fan filter units which do their own recirculation, still needing outside air originally to do those changeovers.
Excellent.
When you start to get into higher class levels, ISO 5 to 8, let's say 8 being the least stringent amount of air filtration, then you can start to see non-unidirectional flow. It's not necessarily needed. Return air could be actually in the room. There's no subfloor now, pulling it down in a straight laminar way, but you're meeting all of your kind of air movement requirements in that sense. In that ISO, one quick mention also on scales and regulations. There's also GMP, good manufacturing practices, within life sciences, within a lot of the pharmaceutical applications, whether it's pharmaceutical compounding or even higher tech FDA regulated biopharma gene therapy type research applications. GMP grade A through D, A, B, C, and D kind of follow along that ISO 5 to 8 scale. So just another regulatory scale to mention: GMP grade A, B, and in a medical environment, whether it's a pharmaceutical or medical device, you tend to move through those stages of a room. There's going to be a section of the room that's grade A, and then something gets packaged. And now things are more self-contained, and it can move to grade B and grade C and move through that room and through different class levels of air filtration. And then lastly, filtration itself. You tell me if I'm jumping ahead, but that would
go for it.
You're either that's airflow pattern, that's kind of air delivery options from an air handler standpoint, including FFUs, and then this type of particulate class and level of filtration is handled by either HEPA or ULPA filtration. You're going to have ULPA filtration often for those most stringent requirements. Generally speaking, you see a lot of HEPA filtration get used.
So you used a term there I haven't heard in a long time. Am I pronouncing it right? ULPA?
Yeah, just ultra low.
Ultra low
ULPA.
HEPA.
Yeah, basically that's it.
Is that what it is?
They're all 99%. The difference becomes how far out from the decimal you go. And ULPA is like 99.9999.
Wow.
Whereas HEPA is 99.99.
What I'm hearing in all this is make sure you work with someone who knows what they're doing.
Yes.
There's a lot going on in these spaces.
Good. I'm checking myself too. 99.97.
Yeah.
Would be HEPA. 99.999 starts to get into ULPA or ultra low.
Wow.
Filtration.
That's serious stuff. So I was going to pull up this image here, and I don't know if a lot of what we just went over is represented in this photo, but I thought visually maybe, because there's a lot more going on in these clean spaces than I had imagined. So maybe we could talk about this photo for a minute, and I'm going to go ahead and make this a little bigger.
Yeah.
So folks, and if you're listening to this podcast in the future audibly, you can see the video version. Some of the podcast platforms have the video, but you can always go to our YouTube channel, which is at HVAC-TV, and you see the video version of this where you could see what we're looking at. So why don't you walk through what we're looking at here? Maybe I'll even blow it up just a little bit more.
Sure. Yeah. So, we basically have a cutaway animation of a section of a clean room in a 3-level structure with a roof. And if we started at the top, roof level, let's call that at the very top, that's a makeup air handler.
This is just for the outside air.
Correct.
Now let's park there for just a second. So
Mhm.
in these facilities, is it common to have energy recovery? Is energy even a thing? Like we do grow rooms a lot, right? Grow
Mhm.
rooms don't typically care about the energy at all. They're like, make sure it's this temperature and this humidity. That's all they care about. Is that the same in these types of spaces, or is there a little more attention to energy recovery, or what's your experience with that?
Energy efficiency is a very important topic
Okay.
to most of these facilities. Again, most of what we do is in semiconductor. I'm tending to give you that context. Very, very important for them. These large companies can often be the largest consumer of energy in the cities or counties that they reside in. So naturally, they're driven by a lot of just honest ESG governance and wanting to be a good steward of the environment, as well as they're going to get certain benefits and tax savings to become more and more energy efficient. So we talk about energy efficiency in general all the time with these large semiconductor companies. You would know that on these larger air handlers, what Hunter pioneered is the fan wall, fan array technology, and that speaks a lot. We really don't do anything but that now, and we absolutely get into conversations about better energy efficiency in that regard, even when we're talking about semiconductor.
Because these things too are running 24/7. I'm assuming there's no break. It's not a 9 to 5 deal. It's 24/7. Okay.
No, these facilities never shut down.
Right. So energy is important. Got it.
And then you'd move down from roof level. That next level, that's meant to represent a recirculation air handler that could then go down, delivered recirculated air exactly to the level below it. And what we call that level below it is the interstitial space, or top side of the actual ceiling grid. And obviously the three people standing there is meant to represent the actual clean room. So if you did dress out top to bottom in what some people call a bunny suit, and you walked into one of these clean rooms and looked up, you'd see a lot happening, especially in semiconductor. There's a ton happening at ceiling level with respect to material handling and robotics. But you may never even realize, and if you didn't know any better, what's actually above that and what's going on in multiple levels. And the three basic components that are shown in that illustration in that interstitial space, left to right, would be an example of on the left. That'd be example of a plenum.
Okay.
So we talked about that we make plenums in two varieties. You could either have air pumped into that plenum from a recirculation air handler that would be sitting on top or at that level above it, as shown. Or you see these little kind of green squares. We actually make fan powered plenums as well, and we call it a plen pack. It's almost an ultra large fan filter unit with multiple fans, and these are all typically BLDC EC controlled fans that you can run and speed up and speed down for efficiency. Even the railing being shown in there is what we do. The railing on that plenum for safety. Every component that we make is walkable. All our ceiling grids are walkable ceiling grids. This is environments we get into that tend to be serviceable spaces with people up there working. Filtration can be switched out, clean room side or top side, but commonly it's top side. Plus you have all these components to service at various times. Moving to the right of that's meant to represent just kind of a distribution box with ductwork that's taking air from that recirculation air handler and then ducting it down to ducted filters that would be located in each kind of grid space. as shown in that ceiling grid. This is kind of meant to represent 2 feet by 4 feet grid, so to speak. And that's an example of where you would use an RAH, mezzanine level, and ducted filters to accomplish what you need. Moving over to the right of that, those 3 black boxes are meant to represent fan filter units. So then as an alternative to recirculation, you would have FFUs or fan filter units that we design and manufacture and are made to just drop in to the standard 2x4 or 4x4 grid spaces that are part of our grid design. And then there's one more component. You can kind of see a white pipe running the depth to the back wall next to those FFUs in that last grid section. And that's just meant to represent a sprinkler main. So we also get into designing and having to integrate utilities into these ceiling grid systems like lighting and fire protection. Our grids can come pre-wired for lighting, for ionization, fire protection, sprinkler mains. We've got our own designs that, can show up lift in place and save time on installation. And then we have hard pipe and flexible hoses to sprinkler heads that we've standardized on. So you're integrating fire protection, lighting, and all these other utilities into this ceiling system architecturally as well.
So the Nortek CleanPack on the 3rd level here where my cursor is kind of circling, all of that is constructed by Nortek, including the walls of the clean room, the ceiling, or is it just the ceiling and all the gear above the ceiling?
Correct, the latter. Where walls and doors and floors are very important in a clean room environment, and today handled by companies other than ourselves, we're all about the ceiling grid. So everything from that ceiling up is what Nortek CleanSpace is all about. Yeah, and one of the things we tend to emphasize is we can differentiate ourselves from some of our competitors in that we do offer all of that.
Right.
There are some competitors we have that only do ceiling grid. There are some competitors that only do air handling. And it really becomes one system. They interact with each other in a very complex and important way in these most stringent clean room environments. And we've got the expertise for all of it.
So a good single source design to construction responsibility. Exactly. I love it. So let me make sure I got this. And so if you're watching this, I'm going to follow my cursor along with my words to see if I get this airflow right, because I want to make sure I understand it. So I'm going to start in the space. This is representing return air. Is it return air is coming up through this plenum?
No. Return air would be coming up through a return air chase,
which is you can't see here. Is that correct?
Right. It's not represented.
Okay.
In this
so
illustration,
it would go. Where would the return air go? To the middle unit?
Yeah, it's either sent back to the recirculation air handler. In that case, where that's how you're doing it with plenum or ducted filters. In the case of fan filter units, it's return air chase would typically be in the wall. You could also incorporate coils in return air chases if you're preconditioning temperature, and then that air is just pumped into that interstitial space.
Got it.
Another thing we get into is the fact that sometimes that interstitial space could be a pressurized space or non-pressurized. The grid, each grid section of a ceiling needs to be sealed, of course, as each component goes into it. If there's not a filter, if there's not a light troffer, you typically have, if there's not a plenum, what's left? You can't have an open square in your grid. So we just do blank pans. Again, all walkable, all have to be sealed to create that interstitial space, a confined space. And that's where we even start to get into options that include, are we going to seal that with a gasket?
Mm-hmm.
Are we going to seal that with gel? When we talk about a pressurized interstitial, we tend to always go with a gel seal, which is your highest level of ensuring there's going to be no leaks.
Mm-hmm. And is this right here an interstitial space? Is this another photo of?
Mm-hmm. Yeah, so that photograph you have there shows the real deal on a lot of what we've just been talking about. That in the back left, so to speak, in the background a little bit, that's a recirculation air handler mounted directly to an air plenum. To the right of that is that fire sprinkler main pipe I spoke of, and an example
right here?
of a couple of, yep, exactly. A couple of flexible hoses there. In front of that are some return air grills, and right behind that are 3 ducted filters, is what you see in the back next to the sprinkler main.
Got it. So a lot of stuff going on in there, and you could walk on this ceiling grid.
Everything's walkable, right? In our design.
Is that common, or is that a benefit we have as we can offer something where someone could get up there and walk on it and service it?
It's common enough. The architectural design and the specification of the space is going to drive whether or not a ceiling needs to be walkable, topside or not. You'd start with what that requirement is. We're a manufacturer that happens to make all components that we do that are walkable. When you start to get into categories of non-walkable ceilings, and then we can almost, to a lesser degree, we can picture suspended ceilings we put in our homes, which are grids, but not walkable.
I've actually learned that the hard way once.
Don't go up into your attic and learn that.
Fortunately, it was a 1-story, 1-floor drop, so it wasn't very high. But I went right through a roof once when I was young. I know that deal.
That you will find non-walkable, what's referred to as T-grid.
Got it.
Or a stick-built grid as well in these higher class level clean rooms. Typically, those modular, put in place, drop-in clean rooms we talked about earlier. You can
ask somebody before you go start walking up on the interstitial space, right?
Absolutely.
I think it's fairly obvious when you go up there, but so and just a quick thing too, like I don't know if I mentioned this before, but Nortek Air Solutions, Nortek CleanSpace, everything shown here in terms of these 2 air handlers and the ceiling grid is all provided by one company, which I think is nice because you can go get your selections and budget. So from an engineering standpoint, how does this go down like a typical plan and spec job where an engineer would call me? Let's say it's a commercial building, office building. He needs selections for a couple rooftop units. It's a VAV system, controls, yada, yada. He puts it on the print. It goes out to bid. Do these happen in the same manner, or are these usually bought by the owner or GC, or how does that typically go down in the construction business?
It can vary in these clean room environments. We certainly talk about whether or not it's design build or, something predefined and drop in. The larger scale projects our business tends to get into in semiconductor is very spec driven, all design build. Who drives that spec, that can vary as well among these various semiconductor companies. We will often be talking very closely, working very closely with the end user, with the semicon fab owner. But likewise, we're heavily involved in talking to architectural AE firms and contractors, both general contractors, installing contractors. Kind of refers back to what I described as these much larger high-tech manufacturing facilities, which are hundreds of thousands of square feet in a massively complex ballroom style. One department, even within that end user alone, doesn't get the job done. Will often have to work with multiple architects and or contractors, depending on the phases of build out for a facility like that. So our team gets involved very often with contractors and with architects.
Got it. So if somebody's listening to this and wants to contact someone, do they go through the normal rep channels, the normal Nortek Air Solutions rep and their location channels to get to you, or is that a separate deal, or how does that work?
Sure, that's a good question. So again, 2 years kind of in the making right now of our CleanSpace segment, taking a real more focused look at that within our super highly valued and expert rep channel within Nortek. Our CleanSpace team has partnered up with not all reps coast to coast, not all Nortek reps, but some key ones that have taken on the Clean Pack. Again, that all these products are pretty much, as you see in the photograph there, they're pretty much all referred to as our Clean Pack brand of products. All these clean room components. A few reps have taken that on, and then of course we would be included in working with that rep also in all of that spec work, and them in turn working with the contractor. And this path for honestly most or all of our reps, that now includes having to get pretty involved in the architectural AE firm side. Commercial design and an air handler follows a slightly different path than the architectural design.
Right.
And who's that spec owner, both at the end user and what's the architect doing to help write that architectural ceiling specification that really becomes part of the building. You get into tons of structural calculations, seismic bracing and things like that. A lot goes into it. And what for those reps we're also working with, and any channel partner we're working with, we are quick to make sure that we're understanding that architectural path and what's needed from the AE firm, and that it's going to be slightly different from the commercial side or just the air handling components.
Excellent. Thank you for that explanation. And at the end, I'll talk to the audience about how they can get in touch with us and find the right person for their needs. So engineering support, selections, budgets, all that's done in-house.
Yeah,
by
correct.
you and the experts there. So they got that. What a great resource, because it's all like a one-stop shopping, which I personally love. So it's terms of getting educated on clean room design and what you all do. Can you talk a little bit about the lab? I think you have a lab that's being renovated. Is that correct?
In our facility in Tualatin, just southwest of Portland, Oregon, Tualatin, Oregon. We have had a space that includes all of these products. Just in the last year, we launched a brand new ceiling grid product called FlexTrack, which is a stick-built T-grid ceiling, available in more than one variation and a couple of hybrid options that no one else has. We as soon as we released that, which got launched about 4 or 5 months ago, we need to include that in this innovation center. We have this innovation center space at Tualatin that, as soon as we get that shored up, can play host to a much higher degree of end users, reps, GCs, anyone within that whole value chain would be invited to come and actually see the product face to face. All the air handlers, all the plenums, all the ceiling grid options are there. Many of them are already. And again, we're kind of shoring up that space to kind of be a place where we can come start collaborating and talking about a project. But you could also see it firsthand. This stick-built T-grid design of a ceiling grid is especially useful to be able to see that way, because unlike the CleanTrack modular grids that show up in pre-assembled modules, you've got, which has its own benefits. You've got the flexibility with a stick-built T-grid ceiling grid to just have all the pieces show up on site, and the ceiling literally gets fully assembled on site from a pile of parts.
Nice.
So to be able to kind of come to our place and see what that looks like, and even get educated if needed on how to assemble that properly, our capabilities that we're going to have once it's in there. In between the stick built and the CleanTrack FlexTrack stick built and CleanTrack modular, we actually have hybrid versions of the stick built, which if someone prefers a stick built ceiling, we could actually semi-build, pre-assemble modules of a stick built ceiling grid, much like our welded modular frame or CleanTrack grid. And no one else does that. And the reason why we're doing that is if there's a stick-built preference, but someone doesn't have the laydown space or even the skilled labor on site to fully assemble a ceiling grid from scratch, it could be very attractive to have pre-assembled modules show up and just be lifted into place. And no one else has that. Yeah. So between that, we got 3-4 options of ceiling grid. And like we said before, add in all the air handling technology, and you come to Nortek and you could pretty much talk about everything you need in that clean room space from the ceiling on up.
I love it. I love the innovation centers. I love factory visits. We had Joe Neccarello on here from Nortek a few weeks ago, and we were talking about that. Like, how do we get better educated, right? Because we're all about like trying to bring education to the HVAC community. And in my opinion, factory visits are the number one way, because you really get to, I don't care how much you explain to me a panel construction until I see it being put together. I'm like, okay, I get it now, like how it goes connects to the floor. And you get what I'm saying? So it's like, I know it's hard to find the time, especially our engineering community. They're so busy today and they're so stressed for getting stuff out. But I mean, my experience has been I've been in this industry for about 25 years now. My experience has been there's no better way to learn than taking the time, take a couple days to go to, especially if it's out there by Portland. That sounds like a lot of fun. So when that's ready. But anyway, so Bo, thank you so much. This was great. I think we gave everybody a good overview of clean rooms in general, whether they're going to work with Nortek or not. I think we hopefully gave them some good value there. And Nortek has some amazing solutions. So, if you're in the clean room, whether you're an architect, a GC, a contractor, an engineer, you're just trying to learn, I'm going to put my contact information into the show notes, whether you're watching this on YouTube or the podcast later or LinkedIn or wherever. And I also put Bo's contact information on there. I'll put a link in there to Nortek Air Solutions, to the website. And there's a specific area on that website that talks about, the clean pack and all the clean room, Nortek CleanSpace information. So anything else? Did we forget anything? I think we did a pretty good job here. 48 minutes. So.
That's great, Tony. Yeah, I love what you do. Thank you. And as you said, if anyone watching wants to contact Nortek directly, that's fine. They can use myself as the initial point of contact. We got a great team on our side. And if you got a clean room project that you want to talk to us about, we're ready to talk to you.
Great. Thank you, Bo.
Thanks, Tony.